Hi, this is Mrs. James, and I am summarizing how to solve the math problems that you had to do as part of the Hanging Triangles lab quiz. I'm not going to be using exact numbers in here because not all of you had the same numbers for your test, so I'm talking about the strategy instead. Basically, this is what you were given. You were given this distance in centimeters, or length. You were given this length in centimeters. In our triangle, this is our x component of this length vector. You were also given the information that you needed to figure out the force of gravity pulling on the weight. And the weight was suspended right here. There was a force meter here, and there was a force meter here. Step one of this problem is to find theta. So we're going to look at the length involved in this. Here is our adjacent, here is our opposite. So to find theta, you're going to use adjacent over hypotenuse. Adjacent, hypotenuse. Problem that some of you had here, some of you found the cosine of theta, not theta. So to find theta itself, you rearrange for inverse cosine of adjacent divided by hypotenuse. This is in centimeters, this is in centimeters with cancel, and then you get your value for theta. You're going to hold on to that because you're going to use it later. That is the piece of information, theta, the piece of information that links our triangle of centimeters with our triangle of forces. Alright, step two of the problem is to find the y component of our force triangle. We're going to do that using the force of gravity. Now there's two triangles here because the piece of string is coming down to our weight and going back up to our weight over here. These two force y components of the force vector, so let's put them here and here, one coming from this triangle and the other one coming from this triangle. Those 1, 2 y components are acting together to balance the force of gravity. Alright? So, therefore, to find one of those, we are going to take 2 times the y component of the force equals Fg. Fg is equal to the mass of the object multiplied by the g of whatever planet you're on. And on this particular problem, you were not on Earth, so you're not going to use 9.80 meters per second squared. You're going to use whatever is whatever planet you're on. And I gave you that in the problem. So force of t in the y direction is equal to half of mg. Step 3. Now we have an angle and we have one side of our triangle and forces. We're going to find the other side. So we have our opposite and we have our hypotenuse. So sine of theta is equal to opposite, which is here, divided by hypotenuse, which is here. So therefore our hypotenuse, which is ft, is equal to opposite divided by sine of theta. A lot of you got this problem wrong because you did not rearrange our 3-unit problem, our 3 variable problem correctly. So you've got 3 things here. You need to rearrange for hypotenuse, which gives you this, and a number of you did that wrong. So that will get you to your final answer, and the units for that are in newtons.